Hello everyone, we are from Group 3. Today our assignment is based on the trunk roll LTV application using machine learning. Here in this assignment, we are going to discuss about the dimensionality reduction and also its performance hyperparameter tuning. Tarun, next slide. When it comes to the dimensionality reduction, basically first we take the number of input features and its variables and the columns that present in the data set that is described as the dimensionality, and then the process to reduce these features is called its reduction. The dataset contains a huge number of input features in various cases, which makes the predictive modeling task more complicated. And it's very difficult to visualize or make predictions for that training dataset with a high number of performances, where the dimensional reduction technique is very useful for it. Next slide. Why it is important when it comes to the accuracy, it improves due to its less misleading data, and this algorithm makes the data to train faster, and the reduction of the data set feature dimensions helps visualize the data faster, and it also removes its noise and the redundant features. Next slide. The components of the dimensionality reduction is displayed here. Here in the graph, we can see the y-axis and x-axis. Here we can see the circles that describes the data. Next slide. The components are like the filters, wrappers, and the embedded features. Feature extraction. It reduces the data in a high dimensional space to a lower dimensional space, where the space with lesser number of dimensions. Next slide. When it comes to the principal component analysis, this method is introduced by Pearson. It works on the condition that the data in a higher dimensional space is mapped to data in a lower dimensional space, where the variance of data in a lower dimensional space should be maximum. First, we construct the covariance matrix of the data, and then we'll compute it with the eigenvalues. And then these eigenvectors corresponding to the largest eigenvalues that are used to reconstruct a large fraction of variance of the original data. Next slide. These are the methods of dimensionality reduction. One is the PCA, and next is the linear analysis. Next is the generalized discriminant analysis. Next slide. These are the benefits of the dimensionality reduction. It has the removing of some of its features, and it speeds some of the calculations, and the training will be very fast. Next slide. These are the advantages of dimensionality reduction. It may need a lot of processing power, and the independent variables becomes harder to comprehend as a result. In some cases, dimensionality reduction may lead to overfitting, especially when the number of components is chosen based on the training data. Next slide. Hyperparameter tuning and machine learning are those parameters that are defined by the user to control the learning process. These hyperparameters are used to improve the learning of the model, and their values are set before the starting of the learning process of the model. And this model is represented by its parameters. And when it comes to the training process, it involves selecting the best or the optimal parameters that are used by the learning algorithms to provide the best results. And here the hyper suggests the parameters that are top level parameters in controlling the learning process. Next slide. Some of the examples of this parameter is the KNN, the K nearest neighbor algorithm, batch size, number of epochs. We can see in the description in the Jupyter notebook, and number of the clusters. Next slide. Learning performance improvement. Hyperparameters can significantly impact the predictive performance, its robustness, and the generalization. First, we are training the model with multiple data sets that can affect the features. When it comes to the transferring learning from pre-trained helps deal with many of the local minima that may affect in the problem landscape, and adding of more data that will be seen in the Jupyter notebook. Next slide. We'll go to the Jupyter notebook. First, we are importing the packages. Here we can see the pip install lite GBM. Here the GBM means the gradient boosting. This is used for making the data set move faster and give the results in an effective way. And also we are installing the TensorFlow. We are importing the pandas, NumPy as usual, the libraries that are needed. Here we are importing the data set. As we have seen earlier, the trunk role application, we are defining the head, the data frame. We can see the head of those columns like node, operating center, etc. Here we can see the description of the each column like node division, hub connection, box status, manufacture model, all the averages, etc. Can you please scroll down? Down. Next. These
Yeah,
are the
we
columns
just
that we have.
running our results. These are the dataset information. Okay, continue, Shravya.
The main goal of our application is likely to build a predictive model that can accurately determine whether a truck roll is needed or not for the various activities or not. Here, the data set is related to field operations or service calls, where the decision is to send a truck for further assistance is a key factor. This data set includes a variety of columns, both the numerical that provide additional information of each task for the particular activity, and it also provides the information of its location and the comments that are required for the work in progress. And it also has the additional data exploration and pre-processing. When it comes to the shape, here we can see like 36,154 of 55. Next, the information of the data frame. Can you please scroll down? Next. And the above output tells that there are some missing values in most of the columns. Here we can observe that the data set size was 36,154 and the missing data was very less. So we can drop the missing rows. Next. If we can see the description of the data frame, here we can see the summary like count, mean, STD, etc. Next. Here we can know the statistical information of the numerical values. We are defining all the columns by pre-processing and importing label encoder with using encodes is equals to node, operating center, technical type, and the box status, everything. Now we are describing the head, some of the results that we can see here. And next we are seeing the independent variable set in X, the target feature in Y. We are also checking the dimensions of X and Y data sets like X dot shape and Y dot shape. When it comes to the principal component analysis, it is one of the technique of dimensionality reduction for reducing the number of dimensions in big data sets by condensing a large collection of variables into a smaller set that retains most of the large set's information. Since machine learning algorithms can analyze the data more quicker and faster, this algorithm seeks to retain as much as information by minimizing the number of variables in a data set. Here by applying a scale learn decomposition by importing the PCA, we can see the transform of X and also the explained variance. Here we can see the output of the array, and here we can also visualize the features that in the graph. When it comes to the x-axis, we have taken from 0 to 12 and the y-axis from 0.0 to 1. Here we can see the graph, the principal components and the explained variance ratio. The following bar graph depicts that the amount of explained variance compared by various principal components, and the number of principal components as 1. Here we are transforming in of X, and we are also describing the head of the data frame. Here we can see the values, and then we are printing the explained variation per principal component. Here we can see the result as 0.99. When it comes to the data frame shape, now it has been reduced to 34,005, and then the head of the data frame. Next, we are installing the TensorFlow, and we are importing the light GBM, which is the gradient boosting for efficient results. And then we are generating embedded columns like web comments. The model which we have performed is related to utilize pre-trained word using TensorFlow Hub. Next, the code uses a pre-trained word model with 50-dimensional word vectors provided by TensorFlow Hub. These words can be used as a part of neural networks for various tasks such as text classification, sentiment analysis, and lot more. And here we are taking the data frame columns and then performing encoding to convert columns to numericals. And then we are adding the embedded columns to the data set. We are describing the data and the data dot head. Here we can see the result of it. The principal component results of each one, like 0, 1, 2, 3, 4. Here we can see the results. The added principal component values to the data set. And then the head again, the columns of our data set. Then we are splitting the data set into the training set and the test set. Now we are building the model using light GBM model. Here we can see the classifier as an output. And to predict the results, we are taking the Y prediction and X test to view the accuracy and importing the accuracy score. Here we are printing the status. Before itself, we are getting like 0.8227. Here we can see the accuracy as 0.82 without hyperparameter tuning. And the classification report function provides a text-based result that includes the following metrics like precision, recall, F1 score, support, and the accuracy. And next will be continued by Karthik.
Thank you, Saravya. Now I'm continuing the hyperparameter tuning. Hyperparameter tuning is nothing but one of the best technique and model in the machine learning. It gives a best accuracy score when compared to the predefined models. It gives a better results in the running results time. So we're we're actually doing the parameter tuning here using some grid search and all different types of models. We're taking already light GBM model because it's a hyperparameter boosting model. So we taken that and we train that model and we evaluate that model with the tested data. And the data set is showing the couple of results here. Start training score is like 1.5 like that. After training, here is a brief discussion about tuning parameters like it's a parameter that controls the step size of each moving forward, and also it can precise the convergence of may require more iterations like that. And this parameter specifies the number of iterations and approach the how algorithm is goes to through an entire training data set and also gives well data like 1,000 times tuning double of time. So that's why it takes couple of hours, couple of days also, because it takes too much time to load the whole data set. And if the data set is big, it takes more time. So that's why we are not running the result right now. But when you run the result, it take more time and gives the best results at the end of the time. So that's the main reason for this assignment. And also it does the regularization, like a regularization technique is we are preventing the overfitting of the regularization and also gives some strength to the high variance solutions. In a zero point 0.1 case indicates relatively weak regularization because the regularization type only applied the 11 typical refers like L1 regularization, and also the it encourages the sparsity and also the coefficients to the loss functions. These parameters settings indicates the specific configuration of training and also learning the model, uh, and also set the complexity and also gives best generalization models to find the best accuracy and also give the perfect prediction values. After that, we used the LGBM classifier and set the hyperparameters to the parameters, the learning numbers, regularization. Here I explained about the regularization, right? And these are the strength of the regularization is 0.01. We can see here. And also we giving the L1, I said, right? L1. This one also we giving. After that, we training the model again and evaluating the model of the test data. So finally, we got the best result before comparing to the model building. It's like the accuracy score is 0.82, but after that, giving the hyperparameter parameter tuning, we got the result as 0.89 is the best accuracy. So far, we did by using the LGBM modifier model, it gives the best accuracy to boost the accuracy and also the hyperparameter tuning. So these are the classifications we got here, and the precision recall FN score, those all things, and we get the best accuracy so far is 0.89% is the best. After tuning the model, the performance on the model was good, not bad at all, and the model accuracy raised to 82 to 89%. So the hypermeter parameter tuning is one of the best technique in machine learning, gives the best accuracy to boost the actual parameters and also gives the best result at the end of the time. And we used the ROC AUC curve, like showing the curve how it is works on the model performance, and also particularly by plotting the each receiver operating characteristics things. So this is the ROC curve. So true positive sensitive and also false positive sensitive. We taken the true values and the false values, like how the scatter plot show the way from zero to end, and also gives the accuracy price rate of the graph you can see here. And this code allows to visually call the discrimination ability and also numerical measures like performing the AUC and also PUC. Sorry, ROC and curve AUC also. Coming to learning performance improvement, this is the final one. Learning performance is also nothing but is a couple of techniques that were used in our machine learning problems, like improving performance data, improving performance algorithms, improving the algorithm tuning and ensembles. Coming to the ensembles, we use couple of tree-based algorithms. That is nothing but here we can see the we used the couple of performance in the algorithm. This approach is selecting the well-suited problem to hand and different algorithms to strengthen the weakness. And this also improves the algorithm tuning. This light GBM I already explained before, and this gives the organization common techniques also for the hyperparameter and fine tuning hyperparameters such as learning rates, regularization strengths, and model architecture, etc. Already we have the permanent performance tuning executed. We can see earlier, and also we given the best result like 89 accuracy. And here we are ensembling the algorithms in our learning performance improvement. So here we're taking a couple of algorithms like using the classifier models random forest. It is one of the tree-based algorithm, because with this tree-based algorithm only we can give the ensemble of giving future elements like future improvement to performance, like learning the and And also one more we used like decision tree, random forest, and also the ADA boost. These three are like well trained tree algorithms that ensembles the perfect algorithm. I mean the accuracy at ending the boosting time, and also gives the best accuracy like 81. You can see there all above 80 only. These algorithms are mainly used for the future improvement techniques. And also the most important parameters are based on the estimators and learning rate, AdaBoost classifier and Chrysolve on these all the things. We taken the support vector also at the end because support vector gives it is also gives some probability and linear actions to train the AdaBoost, and also response the test of the data set how it is working, and we print the accuracy here like that. And here we used the SVSE base estimator because of the learning it accepts much weight decision tree and support vector classifiers. These three are the main assembles the methods involved in the multiple models like predictions and also the random forest, AdaBoost, gradient. These all algorithms can improve the generalization capture complex things like. So that's all from our end. We did the learning performance improvement and hyperparameter tuning and also the model building stuff, and also um, different important things here. And that's all team supported very well. Thank you all guys. Thank you, ma'am, professor.